Assalamu alaikum wa rahmatullah. In this video I am working on another question from the file of question 16 of the coverage. So question 16 has many suggested questions for the final exam. Many of them are similar to the one I did earlier. I mean question 16 number 1. So please practice as many questions as you can. So in this question we are given a table that represents the temperature of the water at selected T values, and T is measured in minutes from 0 to 20, and we have to answer 4 parts. Part A says use the data in the table to estimate W prime of 12. So the estimation of W prime of 12, we did similar thing in unit 2, maybe unit 3, I think unit 2 back in grade 11, but to find or to estimate W prime of 12, we can say it's going to be W of, choose a value from the table bigger than 12, which is 15, minus W of another value smaller than 12, which is 9, divided by 15 minus 9. So if you select those numbers from the table, W of 15 is 67.9 minus W of 9 will be 61.8, divided by 15 minus 9, and W prime of 12 will equal to, I think it's 1 point something. If my memory serves me well, it's 1.0717. Okay, so yeah, it's 1.017. Okay, so we need to interpret the meaning of this answer. Well, this is like an average rate of change, or yeah, we use the formula for the average rate of change. So we can say that the water temperature is increasing, because this number is positive, is increasing at a rate of 1.017 degrees Fahrenheit per minute, right? At T equals, what was the value? 12. At T equals 12 minutes, okay? 12 minutes. So this is for part A. Okay, so for the second part, it says use the data in the table to evaluate the integral from 0 to 20 of W prime of T dt. Okay, so we can use the fundamental theorem of calculus here. So because for part B, let me just, okay. For part B, W prime of 20, sorry, not this one. Come on. So the integral from 0 to 20 of W prime of T dt is equal to W of 20 minus W of 0, and this is the FTC, the fundamental theorem of calculus. And W of 20, if you look back at the table, it's going to be 71, right? So it is 71 minus W of 0 will be 55, and the difference is going to be 16 degrees Fahrenheit. So what does that mean? That means the temperature of the water has increased by 16 degrees over the interval of 20 minutes. So we can say that the water, just a little bit of a space, the water temperature has increased, or the water has warmed, right, by 16 degrees Fahrenheit over the interval over t equals 0 to t equals 20 minutes. So on a duration of 20 minutes, the temperature of the water has increased by 16 Fahrenheit, or 16 degrees Fahrenheit. Okay, so for part C, it says for the whole interval from 0 to 20, the average temperature of the water in the tub is 1 over 20 times the integral from 0 to 20 of W of t dt. Use a left Riemann sum, okay, a left Riemann sum with the 4 subintervals indicated by the data in the table to approximate this quantity. And does it overestimate or underestimate the average temperature? So let's see. Okay, so for part C, we need to approximate this quantity, 1 over 20 times the integral from 0 to 20 of W of t dt using a left Riemann sum. So to do so, keep the 1 over 20 in front, okay? Keep this 1 over 20 in front, and then start using the left Riemann sum over using 4 subintervals. So the first one will be from 0 to 4, and then from 4 to 9, and then from 4 to 15, and then from 15 to 20, and every time, or each time, you need to multiply by the left corner. So this is a left Riemann sum. So we will have 4 minus 0, 4 minus 0, this is the width of the first subinterval, times the height, the left corner will be 55, plus the second width will be 9 minus 4, times the left corner will be 57.1, plus the third subinterval 15 minus 9 times the left end point. The left end point is 61.8, and the last subinterval, the last rectangle, will be 20 minus 15 times the left end point, which is 67.9, and this is all multiplied by 1 over 20 in front. Do not forget the 1 over 20. And that gives you the final answer is going to be 60.79. It's 60.79. Now, to answer the second part, says, does it overestimate or underestimate the average temperature? Well, first of all, the question says that the temperature of the water in a tub at time t is modeled by a strictly increasing. So it's going to be increasing. Look at this one. So your function is increasing and you are using the left Riemann sum. Now, if you are using the left Riemann sum, that means you are not including this portion in your approximation. That means it is underestimate. It's underestimation, or it underestimates the average temperature. Well, if you want just to write an explanation, this sketch will be enough, or you can just say that W of T is increasing or strictly increasing. W of T is increasing. Okay. W of T is increasing, and the left Riemann sum is used. That's why it's underestimated. Okay. So for the last part D, let's go back to part D. It says, for another interval from 20 to 25, the function W that models the water temperature has first derivative given by W prime of T. Based on this model, what is the temperature of the water at T equals 25? So, for part D, we need to find what? W of 25. We are given W prime of T, and we know from the table what W of 20 is. So we can say that the integral from from 20 to 25 of W prime of T dt is equal to W of 25 minus W of 20. Now W prime of T is given, so this is the integral from 20 to 25 of W prime of T, which is 0.4 root of T cos of 0.06 T dt is equal to W of 25, which is what we are looking for, minus W of T. W of T, look, W of 20. Look at the table. W of 20 from the table is 71. So this is 71. Now evaluate the left-hand side. Evaluate the left-hand side in your calculator. You are going to get 2.043 equals W of 25 minus 71. So you need just to isolate W of 25 by adding 71 on both sides. So W of 25 is equal to 73.043 degrees Fahrenheit. So this is the temperature of the water at T equals 25. This is all about question 16. Question number 2 from question 16.5. Good luck. See you in the next video.